Our next pitch comes from Secondcell Bio and Kambi Shekhtar. This company speaks to the drug discovery process, where currently pharma cells that are used in research are not really true to how cells behave in the human body. They act differently, and this can often make the discovery and research process very frustrating. So Secondcell is looking to change that.
Thanks.
Thank you.
Thanks, Melina and the BioLabs team for organizing this fantastic organization. And if anyone is interested in what we're doing, I have to dash right after this. So the BioLabs team is happy to make introductions. Also, my colleague Ramsey is here with the orange phone. As Mike had said, drug discovery is a very difficult process. I believe platform technologies before their launch have to be thoroughly validated. The science has to be really validated. The technology I'm going to present, I invented at the Rockefeller University when I was a graduate student in 1999. Over the past 25 years, we've raised $150 million from customers to access targets that were thought of as untouchable. It's never been partnered with venture firms before. The road has definitely not been a straight line, but thanks to that history, we have a highly validated platform technology that's available for partnership for the first time, and that can change how we discover drugs. In drug discovery, people use cells as detectors to find drug candidates to put through the rest of the process. However, a cell is not a cell is not a cell. Just like there's lots of different people around the world, cells in a petri dish are vastly genetically diverse. Our technology allows us to scan orders of magnitude greater numbers of cells than previously possible to find the exceedingly rare cells that, through their own unique genetic makeup, are able to express disease targets exactly as they exist in the body. And if your detectors are better, everything's on better footing. I'm going to show one data slide for GPCRs. These are important drug targets, very difficult to express in lab cells in their native form. We enabled 25 of the most notoriously difficult ones in their native form, and I'm showing you here our data compared to competitor published data where they use modified forms because it's easier to work with them. They're not the same thing. Drug discovery fails 98% of the time. These detectors are the starting point. Yes, there are many points of failure, but if you're starting on the wrong footing, it's not a good place to start. And if you do AI drug discovery and you have to validate those AI predictions using wet lab models, and you use mutant receptors to do that, not a good place to start. What I'd like to propose, in these many years, we've made our process very cookie cutter. There's 400 GPCRs, 50% of FDA drugs target GPCRs. One biotech goes after this one, the other goes after that one. We can crank out all 400. It's not to say let's discover 400 drugs, but you could. My proposal is let's start with 400, see where do we get good compounds, where is their FTO, where are they safe, whatever are the criteria. End up with compounds that check off all the boxes, and at the very end use clinical input, use market input to say these are the 3, 4, 5, 6, 10 that we're going to cherry pick and develop for commercialization. Thanks.